And we're going to talk about atoms and how we think about that, like we did in the last chapter. So this is a model of an airplane, a jet, and they're using it in a I forget what you call it. They're looking at the airfoils and they're looking at the aerodynamics of this model. We're going to talk about models in this section. So we're going to talk about models of what we think. Some models are physically about theoretical ones, like what we can imagine. We're going to use models in our class. This is one example of how the model is changed about that in this section. So Rutherford, remember, figured out the nucleus, and he did that cool experiment that I love. And he had a great model, but there was some problems with his model. So he was not able to explain chemical properties of elements, which we have to have. We need to know why atoms can react with other elements and form new compounds. So his model could not show why objects change color when they're heated, so they kept looking for a better explanation of the atom and how it's put together. So here's a timeline. Way back in the day, we said John Dalton said that there's atoms. J.J. Thomson figured out that there's electrons, and he thought of it kind of like, he's from England, so they eat plum pudding, so he thought of it like that. So each one of these was a little plum, but you can think of it like a chocolate chip cookie. Here's the chocolate chips, and here's the cookie part. Then a Japanese physicist came up with the central nucleus idea. Rutherford did an experiment and showed that. And then Niels Bohr came along, and he proposed this model for the atom. We've got the nucleus is positive, then we have electrons that spin around the center like solar system, where the electrons go around in these orbits. And then later on, we thought this was limiting this model. The way we think of the atom is limiting to what was really happening. And then Schrödinger came along and used math to say, hey, protons and neutrons are in the center, but electrons are spinning around and buzzing around. I think of them like bees. They're buzzing around in this area on the outside. And they move so fast we're not sure exactly at any one time what they are, but we know overall this is the pathway that they take, and they just move in complex patterns. So we think of the electron cloud. We think of it like a cloud, like looking at this over time. This is basically where the electrons are, but we're not exactly sure at any one time where they are because they move so fast. So let's talk about the Bohr model. He said there was pathways, orbits around the nucleus for the electrons. And he said that these electrons live in energy levels, which we still think of. We just think of it in a little bit more expanded way now. And a quantum of energy is the amount of energy required to move from an electron from one level to another. And this explained that the metals, when they heat, they change color. So this helped explain that. And he thought that electrons had a particular energy level. So if you climb a ladder, it gets harder and harder as you go upwards. And he said there's energy to jump to this ladder level. There's more energy to get to this rung. We don't hang out in the middle here. Our feet are on the rungs. So that's the way he thinks of the energy levels for electrons. They have a particular energy at this space. They need a jump space. And so that's the way he thought of energy, and they're not evenly spaced. The higher levels have more energy, and the lower levels have less energy. So how does that help? Let's talk about the quantum mechanical model. And this shows that energies, it shows the allowed energies the electrons can have and how likely there are to be found in various locations. And so this is the math model, so it's hard. We can't show you the math of it because it's complex, but overall we found that in a particular probability shape, three-dimensional shape, by using these calculations. And so this is called the quantum mechanical model, and this is the one we're using at this time. And this is the modern theory of the atom. So if you imagine looking at an airplane, and this looks blurry because we're not exactly sure where the blade is at that time. That's the way we think of the shape of where the electrons live. They're in there somewhere. We're not exactly sure at any one time where they are, but they are in this particular three-dimensional space. So it's like a photograph of this propeller blade, or looking at a fan. You're not exactly sure if it's moving really fast where exactly the fan blades are. So we call that three-dimensional space this probability cloud right here. It's a fuzzy cloud because the electrons move so fast we're not sure where they are, but they live in that particular area. So we can think of the general place where they live, and we can also think of smaller areas where individual electrons can live. That's called a sublevel. So orbital is the region that we think the highest probability of where the electron is in that fuzzy shape that we're thinking of. And each sublevel has a different shape to it. So these are the shapes that we think electrons buzz around in. And so S's are spheres, so we need to know that. So electrons are buzzing around inside the shape. Most of the time, 99% of the time, they're inside here, but every once in a while they sneak off, but most of the time they're in this round spherical shape. P orbitals look like dumbbells, so electrons there's one electron buzzing around here, there's one electron buzzing there, one there, one there, one there, one there. So these are P's, so we need to know the shapes. So 2 electrons can fit in this shape, one can fit here, one can fit there, 1, 1, 1, 1. So S's can hold 2 electrons, P's can hold 6. And D's get more complicated. So you have 1, 2, 3, 4, 5, and this can hold more electrons. And then there's even higher level F, which is even more complicated, and it's so complex it's hard to show. So these are the principal. This is kind of like what Bohr was thinking. There's a orbit close to the center, there's another orbit farther away, third level, fourth level. These are kind of like the rungs of the ladder. And then nowadays we're thinking, we can kind of think of those as the outermost boundaries, but they also live within different smaller shapes within that outer boundary. Okay, so this is complicated and it takes a while to get, so you're going to need to read through the book so you can understand what this is all about. But this, I'm trying to give you like a general overview to get you started. So another thing to think is how many electrons can live in each level. So it would be good if you knew this. At energy level 1, we can only hold 2 because it's in that S shape. When we get to level 2, we have S's and P's together, so we can hold 8. So it gets bigger and bigger as you go down. So as the element is farther down the periodic table, it can get bigger and bigger and hold more electrons. So let's see how you do on this quiz. So what was wrong with Rutherford's model? I hate to say there's anything bad about Rutherford, but his model, not him personally, but his model couldn't explain something. What was it? So he couldn't show the chemical properties of elements, which we have to have in chemistry, so we had to continue on with the theory and move on and get a better theory. Happens in science, we got to improve on the theory we have. So Bohr's model, what do you think about Bohr? Electrons are found. What do you think? So he said they're in circular orbits like the solar system. And last, which is the lowest principal energy level in which p orbitals are found? So this you might not quite know yet, but we'll get used to it once we look at a periodic table. So it's the second period. So we'll talk about that soon. So I hope you learned a little bit about electrons and where they live. All right, talk to you soon. Bye-bye.